Greetings, humans. How's it going? Awesome? Good. Great. Fantastic. We're going to be talking about combinations today. Now, a combination, mathematically defined, is any selection of objects where order is not important. Order is not important. The combination has a cousin, permutations, if you remember discussing those, and permutations, order does matter. So that's like first, second, and third place we award, or a specific position like president, vice president, and treasurer, say. But where you have distinct positions and order matters, that's a permutation. Where you don't have any particular order, where order does not matter, that's any combination of events. So we're going to be talking about these combinations. Here we go. Let's suppose we have 5 basketball teams, A, B, C, D, and E, and you wanted to list the possible matchups between all 5 teams. So A could be playing B, A could be playing C, A could be playing D. You follow me? A with E, and so on. And here it is. We listed every single possible combination, except I'm not sure I did this right. I have A with B, and then I have A with C, A with D, A with E, and then I have A with B. Wait a second. A with B is the same thing as B with A. So I've actually overcounted here. So let's get rid of this one as not to be redundant. Then we have B with C, B with D, B with E. And as you see here on this next row, we are also being redundant with this item. C with A is the same as A with C. And C with B, right above it, we had B with C. So we've overcounted in this way. And you'll notice as you go through this, this is a recount. Same with this, same with this, then same with all of these on the bottom. So any combination would mean any matchup, no matter whose name is listed first. So we're actually looking at all these ideas right here. If you have 5 and you're choosing by way of a combination, and it's a combination because order doesn't matter, combination, and you choose 2. We're going to define this mathematical wonder here on the next page. Turns out that when you have n and you're choosing r elements from n elements with any combination, the formula is looking at the permutation of that same choice, n choose r, over r factorial. Mathematically, how this works out, because we know that to have n choose r with a permutation, that's equivalent to the factorial of n over n minus r factorial. But if that's being divided by r factorial, that would be the same as saying this. Dividing by a number is the same as multiplying its reciprocal, 1 over r. So really this statement, this one here, is the same as that one there. So really, oh gosh, if you have n choose r, any combination is equivalent to n factorial over n minus r factorial times r factorial. Goodness gracious. That's as fun as a dance party in the rain. Okay. So this is fun. Let's see it with some numbers. Going back to the basketball example, if you have 5 basketball teams, how many unique games can be played? Again, with the thought that B playing A is the same as A playing B, we know that it's a combination, because the order in which these things are lined up doesn't matter because you have the same teams playing. Okay, so now that we're comfortable with the fact that it's a combination, let's consider the fact that we are choosing from 5 teams, 5, and we're choosing 2 to play at one time. How many combinations do we have? Well, any combination is the same as the permutation of 5 to choose 2 over what you're choosing, the r, factorial. Okay, I'm looking at permutation of 5 choose 2. Again, that's 5 over 5 minus 2 factorial, and then 2 factorial. Dance party! DJ Lemon! Pipes are going up. It's a Wednesday. All right. Okay, that was a major interruption of the pipe and the air in the pipe, making that awesomely obnoxious noise. So here we are. Now we just got to do some maths. This can simplify. The numerator stays the same. On the bottom, the denominator has a factorial of 3, 3 factorial, 5 minus 2, and then 2 factorial. Well, the top is really 5 times 4 times 3 factorial. Maybe you know why I stopped at 3 factorial, because there's a 3 factorial in the bottom. You can see that 3 factorial will cancel or divide with this 3 factorial. And 2 factorial is just 2 times 1, so it's really just 2. So we can actually divide a 2 from the numerator for 1, divide a 2 from the denominator. Sorry, a 2 from the denominator down here is 1, and a 2 from the numerator gives you a 2 up there. Really, the number of unique matchups is 10. We could go back and see that the original list I had represented 10 unique games. Pretty crazy. Here's an example. Your English teacher says that you need to do 4 book reports over the course of the year. And she gives you a list of 7 books to choose from. So as long as you do 4 book reports, you're okay. She does not say that you have to do a particular book first, second, or third. She just says, hey, do 4 of them, 4 books out of the 7. So order doesn't matter. What matters is the fact that you have any combination of the 4 book reports from the list of 7 books. So it sounds like you're choosing from 7, you're choosing 4. Order doesn't matter, so we're using this combination. And any combination can be written as a permutation divided by whatever you're choosing, its factorial. So here we have it. Let's take a look at 7 over 7 minus 4 factorial, still with the 4 factorial, don't forget that. That's the most common mistake. Now let's simplify. You've got 7 times 6 times 5 times 4 on the top. On the bottom, 4 factorial I should say, on the bottom you've got a 3 factorial and a 4 factorial. Goodbye 4 factorials. Haha. Now let's dissect this 3 factorial. It's 3 times 2 times 1, which today I believe is 6. So instead of having this and this, we really have 6. 6 on the bottom can divide with this 6 on top. So as you see, 7 times 5 is 35, and your numerator is completely simple. So 35 over 1 is 35 different ways of writing a book report for this English class. In class? I need to go to English class. Class? Okay. I'll talk to you later. Have fun with your homework. Oh, do your homework. Wait, what? Okay, bye.